All right. In this video, we're going to go over a really, really important concept known as modeling. It's known as modeling. And I'm going to be more specific. It's modeling with functions. Now, modeling does not mean like walking on a catwalk. Okay? To model something, it means can we sort of explain the data through a mathematical equation? And this is one of the most important things in math, where we get some data, and what we want to do is describe that using an equation, because we understand equations way better than just random data. So let me give you an example of this. So let's take, for example, this situation where I have some random person called Jose. I'm just going to put a little. So Jose runs at a speed of 5 meters per second. Model his distance over time. So what we're going to do, we really have two variables here, and those variables are distance and time. So the first thing I'm going to do is I'm going to say let d be distance, and then let t be time. Now, one more thing is that when I'm defining distance, I should probably define distance in a certain unit. So for distance, I'm going to say that's meters. So I'm going to put an M, that stands for meters. And for time, I'm going to put seconds, which really fits neatly since we have, since Jose is running at a speed of 5 meters per second. Okay, next, the best way to sort of model this is you sort of draw an XY plot, and we're going to see how Jose sort of runs over time. So let's, for example, if you draw this XY plot, so here's X, but I'm not going to call it X. Here, instead of our X, what we're going to call is time. So we usually put time on the X-axis, and this is going to be measured in seconds. And for the Y-axis, it's going to be distance, and that's going to be measured in meters. All right, so let's see how this works over. Let's see how this works. So, for example, time, we're always going to start with a time of 0, then 1 second, 2 seconds, 3 seconds, and 4 seconds. Let me just scroll down a little bit. And then for distance, I'm going to put this in units of 5, 10, 15, and 20. All right, so let's see how Jose runs over time. So if Jose is starting to run at the time of 0, well, he hasn't really started yet. He hasn't moved yet. So our first plot will be right there. Okay. After 1 second, since he runs at a speed of 1 second, he has covered a distance of 5 meters. So at 1 second, that's where our next point will be. At 2 seconds, well, he's covered another 5 meters. So that's from 5 plus 5, that's 10. So at 2 seconds, it's right there. At 3 seconds, he's obviously run 5 more meters, so that's going to be 15, which is right there. And at 4 seconds, he's obviously going to run 20 meters. And basically what we can see right here is that we can just sort of connect the dots, if you will. And so we can basically connect the dots right there. And what we get is a linear equation. It's obviously my points are a little bit off. I'm just going to move them actually a little bit so they sort of fit the line. Oops, they fit the line. Oh, they're not moving for some reason. But oh, wait, there we go. So that's 2 and 10, and that's right. So really, they should all fit in one nice, neat, straight line. And now the question is, how do we model this function? Well, we know a lot about linear equations, and in linear equations, we need two things. We need the y-intercept, and we need the slope. So first of all, what's the y-intercept? Well, in this case, the y-intercept is right at 0, 0. So we know our y-intercept is 0. And what about our slope? Well, for every second, so he runs 1 second here, he covers 5 meters. So our slope is 5 or 1, or it's 5. So the way we're going to model it, now normally, if we didn't have distance and time, we would model this as y equals 5x, since 5 is a slope, plus 0, and 0 because our y-intercept is 0. But since we're modeling this function, we're going to express it differently. The way we're going to model this is we're going to say our distance at t, so d of t, is equal to 5 times t plus 0, right? Because t is our x-axis and d is our y-axis, and we say d of t, meaning that if we wanted to figure out the distance at a particular time, we'd have to write it this way. So if I were to carry on with this question and ask you, like, at what time or at what distance is Jose going to cover after 30 seconds? Well, what the distance he's going to cover after 30 seconds is, well, that's easy to find out. It's d of 30, since it's 30 seconds, is equal to 5 times 30 plus 0. And 30 times 5 is 150. And we can't simply just write 150 since we're talking about units. We're talking about distance. So this is in seconds and that's in seconds, but our distance, which we're measuring, is in meters. So after 30 seconds, Jose has run a total of 150 meters. So the key thing I want you to understand is we have modeled Jose's running speed through this equation. This equation is modeling how Jose runs. And that's a simple example of modeling. I'll see you in the next video.